Hey guys, 9-5 extra practice. So, if we are going to evaluate a finite series for the specific number of terms, this is geometric because we are multiplying by 1/2 to get to the next term. So I am using the sum formula for a geometric finite. So the sum, a1 times 1 minus r to the n power, all over 1 minus r. So I need to know what my first term is, r and n. My first term is 40, r, or we can do 20 divided by 40, which is 1/2, and 10 divided by 20, which is 1/2. So r is 1/2. N is given, which is 10. Plug into the formula. The sum of the 10 terms is equal to 40 times 1 minus 1/2 to the 10th power, all over 1 minus 1/2. We're going to put that in our calculator. Sorry, I thought I had the calculator on the computer, but I don't. But I would be doing 40 parenthesis 1 minus, open a new parenthesis, because I want 0.5 to the 10th power. Close my parentheses, enter, divided by 0.5, and I get 5,105 over 64. Or it's about 79. Determine whether each infinite geometric series diverges or converges. State whether each series has a sum. So we have to remember diverges and converges depends on our ratio. So what is our common ratio? I'm going to do 3 over 2 divided by 3, which is 3 over 1. So I'm multiplying by 1/3, which is equal to 1/2. So my common ratio is 1/2. Since the absolute value of 1/2 is less than 1, I converge. And I have a sum. If we remember the sum formula, the sum is equal to a sub 1 over 1 minus r. So our first term is 3. So the sum is equal to 3 over 1 minus 1/2, which is, the sum is equal to 6. Here I am multiplying by 1/2 again, so r is equal to 1/2. Once again, since the absolute value of r is less than 1, I converge. Since I converge, I can do the sum formula. Sum is equal to 4 over 1 minus 1/2. So the sum is equal to 8. Here I do 15.3 divided by 17, which is 0.9. I do 13.77 divided by 15.3. Just to double check, and that's equal to 0.9, so this is r. So is the absolute value of 0.9 less than 1? Yes. Therefore, we converge. Since we converge, I'm going to find the sum, which is the sum is equal to my first term over 1 minus my ratio, so 17 divided by 0.1. So the sum would be equal to 170. Evaluating each infinite geometric series. Once again, we need to check whether or not we converge or diverge since my ratio is equal to 1/2. I am converging because the absolute value is less than 1. Since the absolute value is less than 1, we can use our sum formula once again. So the sum is equal to 8 divided by 1 minus 1/2, which is equal to 8 divided by 1/2, which is equal to 16. So our sum would be 16. Check again. My ratio is 1/3. Is the absolute value of 1/3 less than 1? Yes, therefore we converge. If we converge, we can use the sum formula, which is first term divided by 1 minus r, which is 1 minus 1/3. So 1 divided by 2/3 is equal to 3/2. Therefore, our sum of this infinite geometric series is 3/2. If I need to determine whether each series is arithmetic or geometric, I need to look at the different pattern, and then I need to evaluate the series for the specific number of terms. So I'm looking at 2 and 5. I'm thinking I added 3. Double checking the pattern, I add 3. I add 3. If I am adding, that means I have a common difference of plus 3, making this arithmetic. If it's arithmetic, I'm finding the sum of the first 9 terms. Therefore, I'm using the sum formula, which is equal to n over 2 times a sub 1 plus a sub n. So the sum of the first 9 terms is equal to 9 divided by 2 times a sub 1 is 2 plus a sub n. We don't have the 9th term, so I can plug that into my explicit formula. A sub 9 is equal to my first term 2 plus n, 9 minus 1 times d, which is 3. So this is 8 times 3, which is 24, plus 2, which is 26. So 2 plus 26, which is 28, times 9/2. Therefore, the sum of the first 9 terms is equal to 9/2 times 28, which is 126. Determine whether each series is arithmetic or geometric, and then evaluate for the specified number of series. I am multiplying by 1/2. Therefore, our r is equal to 1/2, so we are geometric. And geometric number of terms, I have s sub n is equal to a1 times 1 minus r to the n power all over 1 minus r. S, or the sum of the first 8 terms, is equal to 1/8 plus 1/8 times 1 minus 1/2 to the 8th power all over 1 minus 1/2. So this is equal to 1/8 times 1 minus 1/2 to the 8th power over 1/2. Put that in your calculator. 1/8 times 1 minus 1/2 to the 8th power divided by 1/2. And this is equal to 255 over 1024, which is about 0.25. That's all for 9-5.